Hello students, how are you? I hope all of you are good. In my previous video, I discussed the complete introduction part for the exercise 11.2. So in this video, I am going to solve the questions in exercise 11.2. And in that the first question is, show that three lines with direction cosines. So these first three are the direction cosines of the first line, and second three set is nothing but direction cosines of the second line, and third three are the direction cosines of third line, are mutually perpendicular to each other. So we need to show that these three lines with their direction cosines are mutually perpendicular to each other. So as you know that to show that any two lines are mutually perpendicular to each other, we know that one of the condition of perpendicularity of the two lines, that is what, when their direction cosines are given. Suppose L1, M1 and N1 are the direction cosines of the first line, and L2, M2 and N2 are the direction cosines of the second line. If L1, L2 plus M1, M2 plus N1, N2 is equals to 0, then we say that first line is perpendicular to second line. So it means to show that these three given lines are perpendicular, we need to show that first line is perpendicular to second line and second line is perpendicular to third line, then definitely third is perpendicular to first line. So firstly, we need to prove that first is perpendicular to second line. So for that, let us consider the direction cosines of the first line, L1, M1, N1, and direction cosines of second line, L2, M2, N2, and direction cosines of third line, L3, M3, and N3. So to prove that first and second lines are perpendicular, so consider L1, L2 plus M1, M2 plus N1, N2, which is equals to, the value of L1 is 12 divided by 13 and L2 is 4 by 13, 4 by 13 plus value of M1 is minus 3 by 13 into M2 is 12 by 13 plus value of N1 is minus 4 by 13 into N2 is 3 by 13. So now which is equals to 12 into 4, 48 divided by 13 into 13, 169. Similarly, plus into minus, 3 into 12, 36 divided by 13 into 13, 169. Plus into minus, 4 3s are 12 divided by 169. Now observe here, first thing positive plus 48 divided by 169 as it is, minus 36 minus 12 minus 48 divided by 169. So here 48 by 169 minus 48 by 169 is equals to 0. It means first line is perpendicular to second line. Now for proving second and third lines are perpendicular to each other, so consider consider what, L2 L3 L2 L3 plus M2 M3 plus N2 N3, which is equals to, the value of L2 is 4 by 13 into L3 is 3 by 13 plus M2 is 12 by 13 into M3 is minus 4 by 13 plus N2 is 3 by 13 and N3 is 12 by 13. So now which is equals to 4 into 3, 12 divided by 13 into 13, 169 plus into minus, 12 into 4, 48 divided by 169 plus 3 into 12, 36 divided by 169. So now observe here, 12 plus 36 is 48 divided by 169 and minus 48 divided by 169 as it is. So plus 48 by 169 minus 48 by 169 get cancel, answer equals to 0. It means second line is perpendicular to the third line. Now we need to prove that first and third lines are perpendicular to each other. Now we need to prove what? First and third lines are perpendicular to each other. So let's try consider. Now what? Consider L1 L3 plus m1 m3 plus n1 n3, which is equals to, the value of L1 is 12 by 13, 12 divided by 13 into L3 is 3 by 13 plus m1 is minus 3 by 13 into m3 is minus 4 by 13, minus 4 by 13 plus value of n1 is minus 4 by 13, minus 4 by 13 into n3 is 12 by 13, 12 by 13. Now which is equals to, so 12 into 3, 36 divided by 169, minus into minus plus 3 into 4, 12 divided by 169, plus into minus, minus 4 into 12, 48 divided by 169, which is equals to 36 plus 12 is 48 divided by 169 and minus 48 by 169 as it is. So therefore plus 48 by 169 minus 48 by 169 is equals to 0. Hence first line is perpendicular to third line. So observe here, first line perpendicular to second line perpendicular to third line, and third line perpendicular to first line. It means given three lines are, which implies given three lines are mutually perpendicular to each other, I hope all of you understood this question. So let's start the second question. And the second question is, show that line through the points, A and B is perpendicular to the line through the points P and Q. So here we need to prove that given two lines are mutually perpendicular to each other. So first line is AB and second line is PQ. So here he has given that we need to prove that the line AB, so the coordinates of the point A is given here 1, minus 1 and 2, and B is, coordinates of the point B is 3, 4, minus 2, and we need to prove that this line is perpendicular to, the line through the points P point, that is what, 0, 3, 2, and Q point 3, 5, 6. So we need to prove that these two given lines are mutually perpendicular to each other. So where AB is a first line and PQ is a second line. So to prove that these two lines are mutually perpendicular to each other, so we know that if the direction ratios of the first lines are A1, B1, C1, and direction ratios of the second line A2, B2, C2, if suppose A1, A2 plus B1, B2 plus C1, C2 is equals to 0, then we say that this first line is perpendicular to second line. First line is perpendicular to second line. So where A1, B1, C1 are the direction ratios of first line and A2, B2, C2 are the direction ratios of second line. So to prove that these two lines, first and second, perpendicular to each other, first we need to identify the direction ratios of the AB line segment, and then we need to identify the direction ratios of the PQ line segment. Then by using the condition of perpendicularity, we need to prove that two lines are perpendicular to each other. So it means my first step is identifying the direction ratios of first line, that is what, AB. So now what, direction ratios of first line, that is what, AB. So let's say the direction ratios of AB is A1, B1 and C1. And when A1, B1, C1 are the direction ratios of the line segment AB, where A is the first point, B is the second point. Let's say the coordinates of the first point is x1, y1, z1, and second point is x2, y2, z2. So the direction ratios of the line segment AB is x2 minus x1 and y2 minus y1 and z2 minus z1, where A1 is x2 minus x1 and B1 is y2 minus y1 and C1 is z2 minus z1. So see here, the value of A1 is, A1 is x2, value of x2 is 3 minus x1, value of x1 is 1, and value of y2 is 4 minus value of y1 is minus 1, so minus into minus plus 1, and the value of z2 is minus 2 minus value of z1 is 2. So therefore the value of a1 is 3 minus 1 2, and value of b1 4 plus 1 5, and value of c1 minus 2 minus 2 is minus 4. So these are the what direction ratios of the first line segment AB, and we need to identify the direction ratios of the second line segment, that is what PQ. Next what direction ratios of second line PQ. Let's say A2, B2 and C2 are the direction ratios of PQ line segment, where P is the first point, Q is the second point. Therefore the coordinates of the first point P, x1, y1, z1, and second point x2, y2, z2. Therefore, the value of A2 is equals to, therefore, the value of A2 is equals to same thing x2 minus x1, and B2 is y2 minus y1, and C2 is z2 minus z1. Here the value of x2 is 3, so 3 minus x1 value is 0, and similarly value of y2 is 5 minus y1 value is 3, and the value of z2 is minus 2, sorry z2 is 6 minus z1 value is 2. Hence, the value of A2 is equals to, hence the value of A2 is equals to 3 minus 0, 3, and value of B2 5 minus 3, 2, and the value of C2 6 minus 2 is 4. Therefore, these are the direction ratios of the second line segment PQ. I hope all of you understanding. Now what? Apply the condition of perpendicularity. That is what? A1, A2 plus B1, B2 plus C1, C2. If it is equal to 0, then these two lines are perpendicular to each other. So for verifying whether these two lines are perpendicular or not, that's why consider what? A1 A2 plus B1 B2 plus C1 C2, where A1 A2, A1 is a direction ratio of the first line and A2 is a direction ratio of second line, therefore 2 into 3, so 2 into 3 plus B1, value of B1 is 5 into B2 is 2 plus value of C1 is minus 4 into C2 4. Now observe here, which is equals to 2 into 3 6 plus 5 into 2 10 plus into minus minus 4 into 4 16, which is equals to 6 plus 10 is 16 minus 16. So 16 minus 16 is 0. It means we got A1 A2 plus B1 B2 plus C1 C2 is equals to 0, which implies the line segment AB is perpendicular to the line segment PQ. I hope all of you understood this second question. Now consider the third question. And the third question is, show that the line through the points A, B is parallel to the line through the points PQ. So in this question, we need to prove that the line segment AB is parallel to the PQ. So as you know that if A1, B1, C1 are the direction ratios of first line and A2, B2, C2 are the direction ratios of the second line, if A1 by A2 equal to B1 by B2 equal to C1 by C2, then we say that first line is parallel to second line. So it means first thing we need to identify the direction ratios of the line AB and direction ratios of the line PQ. If the direction ratios of AB line segment is proportional to the direction ratios of the PQ line segment, then we call that given two lines are parallel to each other. So here he has the given first line, that is what? AB. So first line is what? AB. So A is the first point and whose coordinates are given 4, 7, 8, and second point is B and whose coordinates are 2, 3, 4. Similarly, the second line is also given, which is parallel to AB. So where PQ, P is what? Minus 1, minus 2, 1, and Q is the second point whose coordinates are 1, 2, 5. So to check whether these two lines are parallel to each other, first we need the direction ratios of the line segment AB. So now what? Direction ratios of the line segment AB. Let's say A1, B1 and C1 are the direction ratios of AB. And A is the first point, B is the second point. Therefore, coordinates of A point is x1, y1, z1, and coordinates of B point is x2, y2, z2. And the value of A1, as you know that x2 minus x1, B1 is y2 minus y1, and C1 is z2 minus z1. So in this point A is 478, B is 234. Therefore, x2 minus x1 is 2 minus 4. 2 minus 4. Y2 minus y1 is 3 minus 7. And z2 minus z1 is 4 minus 8. Therefore, the value of A1 2 minus 4 minus 2. Value of B1 3 minus 7 minus 4. Value of C1 4 minus 8 minus 4. So, these are the direction ratios of the first line, that is AB. And we need the direction ratios of second line PQ. Now what? Direction ratios of PQ. Let's say A2, B2 and C2 are the direction ratios of PQ line segment. And same thing, A2 is obtained by x2 minus x1 and B2 is obtained by y2 minus y1 and C2 is obtained by z2 minus z1, where x1, y1, z1 are the coordinates of point P and x2, y2, z2 are the coordinates of point Q. Therefore, x2 minus x1 is 1 minus minus 1. So, minus into minus plus 1 and B2 is 2 minus 2 minus minus into minus plus 2 and C2 is 5 minus 1. Hence, the value of A2 is 1 plus 1 2 and B2 is 2 plus 2 4 and C2 is 5 minus 1 4. Now, to identify whether these two lines are parallel or not, we need to calculate the value of A1 by A2, B1 by B2 and C1 by C2. Now what? Consider. So consider A1 by A2, where value of A1 is minus 2, divided by value of A2 is 2. So minus 2 divided by 2 is minus 1. Similarly, the value of B1 by B2, which is equals to value of B1 is minus 4 divided by B2 is plus 4. So minus 4 by 4 is minus 1. Similarly, we need the value of C1 by C2. So C1 by C2 equals to value of C1 is minus 4 divided by value of C2 is plus 4. Same thing, minus 4 divided by 4 is minus 1. So observe here the value of A1 by A2, B1 by B2 and C1 by C2 all are equal to minus 1. It means first line AB is parallel to the second line PQ. I hope all of you understood. So the direction ratios of the line segment AB is proportional to direction ratios of the line segment PQ. Hence, these two given lines are parallel to each other. I hope all of you understood this question. So let's start the next question. And the next question is, find the equation of line passes through the point 1, 3, 2 and parallel to the vector 3i plus 2j minus 2k. So observe here, we need to identify the equation of line which passes through the point 1, 3, 2 and parallel to the vector 3i plus 2j minus 2k. So observe here, we know that equation of line passes through a point and parallel to a vector. So see here, we need equation of line passes through this given point and parallel to this vector. And vector equation of the line passes through the point and parallel to a vector. We know that vector equation of required line is what? R vector is equals to A vector plus lambda times of B vector. And also we know that Cartesian equation of required line Cartesian equation of required line which passes through the point and parallel to a vector. So Cartesian equation of the required line is x minus x1 divided by a, y minus y1 divided by b equal to z minus z1 by c, where x1, y1, z1 are the coordinates of the point through which the required line is passing, and a, b, c are the direction ratios of the line or direction ratios of the parallel vector. And in vector equation, r vector is the position vector of the general point, and a vector is position vector of the point through which the required line is passing, and b vector is a parallel vector. So in this question he has given that the required line is passing through the point a, therefore coordinates of this point is x1, y1 and z1, and parallel to this vector it means this is a b vector, and required line passing through the point A. What is the coordinates? 1, 3, 2. It means its position vector definitely A vector, and A vector is equals to I plus 3j plus 2k, and required line is parallel to B vector. B vector is 3i plus 2j minus 2k, whose direction ratios are a, b, c, where value of a is 3, value of b is 2, and the value of c is minus 2. The coefficients of I, j, k in parallel vectors are known as direction ratios of the line. Therefore, the required vector equation of the line is r vector is equals to a vector. So we got a vector. A vector is equals to what? I plus 3j plus 2k. I plus 3j plus 2k plus lambda times of b vector, where b vector is 3i plus 2j minus 2k. So this is the required vector equation of the required line. This is what? Required vector equation of the line. And the Cartesian equation of the line is x minus x1, x minus x1. The value of x1 is 1. So the line which passes through the point 1, 3, 2 are the coordinates of a point, which are known as x1, y1, z1. The value of x1 is 1. So x minus 1 divided by a, value of a is 3, equal to y minus y1, the value of y1 is 3, divided by b, the value of b is 2, which is equals to z minus z1, the value of z1 is 2, divided by c, the value of c is minus 2. And this is what? Required Cartesian equation of the line which passes through the point 1, 3, 2 and parallel to the vector 3i plus 2j minus 2k. I hope all of you understood this question, and this question is important. So let's start the next question. The next question is, find the equation of the line in vector and Cartesian form. We need the equation of line in vector as well as in Cartesian form that passes through the point whose position vector is 2i minus j plus 4k in the direction of the vector I plus 2j minus k. So this question is also similar to previous one, but allen kottidda parallel to direct vector kottidda, and as well as he has to given passes through the direct point kottidda. But in this question he has given that passes through the point whose position vector is given here, whose position vector, and instead of giving the parallel vector he has given that direction vector. So direction vector is nothing but parallel vector. So in this question the parallel vector is I plus 2j minus k, and the required line passes through the point whose position vector is given here. See here, let's suppose this is a given line and this is a parallel vector to the given line. So let the direction vector antanu heluತ್ತೀವಿ ಅದಕ್ಕೆ. So here the direction vector, that is what? B vector. So B vector is I plus 2j minus k, and we need the equation of line in vector as well as in Cartesian form. And let's suppose the required line, let's suppose this is a required line, and required line is passes through the point A. So he has given that position vector of this point A, that is what A vector. So A vector is given 2i minus j plus 4k, and coordinates of the point A is the coefficients of I, j, k in A vector, that is what 2, -1 and 4. So since required line passes through, passes through, passes through which point? 2, -1, 4. Let's say A point, and whose coordinates are defined by x1, y1, z1, and in the direction of, and in direction of B vector. So what is a B vector here? I plus 2j minus k, whose whose direction ratios are, let's say, A, B and C. A, B and C. The value of A, B, C is nothing but the coefficients of I, J, K in B vector, that is 1, 2 and -1. I hope all of you understood. So required line passing through the point 2, -1, 4, whose position vector is A vector 2i minus j plus 4k, and in the direction of B vector, so where B vector is I plus 2j minus k, and whose direction ratios are 1, 2, -1. I hope all of you understood. So now directly use these in vector equation and Cartesian equation of the required line. So we know that, first thing, we know that vector equation of required line is what? R vector is equals to A vector plus lambda times of B vector. So therefore R vector is equals to, A vector is 2i minus j plus 4k, 2i minus j plus 4k, plus lambda times of B vector, where B vector is I plus 2j minus k, I plus 2j minus k. I hope all of you understanding. Now also we need the Cartesian form of equation. So now what? We know that Cartesian equation of required line. Cartesian equation of required line. That is what? X minus x1 divided by A equal to y minus y1 divided by B equal to z minus z1 divided by C. Here the values of x1, y1, z1 is nothing but 2, -1, 4. So substitute here x minus x1 is 2, 2 divided by direction ratios of the line, value of A is 1, 1 equal to y minus y1, value of y1 is -1, so minus into minus plus 1 divided by the value of B is 2 equal to z minus z1, the value of z1 is 4 divided by value of C is -1, and this is a required Cartesian equation of the line which passes through the point 2, -1, 4 and parallel to the vector I plus 2j minus k. I hope all of you understood this question. So let's start the next question, and the next question is, find the Cartesian equation of the line which passes through the point -2, 4, -5 and parallel to the line given by x plus 3 divided by 3 equal to y minus 4 divided by 5 and z plus 8 divided by 6. So in this question he has given that the required line, let's suppose this is a required line, this is what? Required line, and this required line is passing through the point, A point, whose coordinates are -2, 4, -5, and instead of giving a parallel vector, he has given a parallel line to the required line. And let's suppose this is a parallel line which has given in the question, that is what? X plus 3 divided by 3 equal to y minus 4 divided by 5 equal to z plus 8 divided by 6. See here, to identify the vector or Cartesian equation of the line. So in this question is just given the Cartesian equation. So for Cartesian equation, we need what? X1, Y1, Z1 and the direction ratios of the parallel vector. So already he has given that the values of x1, y1, z1 in this question. So the coordinates of the points x1, y1, z1 are the point through which the required line is passing. So in this question, he already given the directly the values of x1, y1, z1. But we need a parallel vector. We need what? Parallel vector. So this is a suppose parallel vector b vector. And see here, if suppose this is a parallel vector to this required line, definitely this b vector is parallel to this line also, because both of these two lines are parallel to each other. It means the direction ratios of this given line, the direction ratios of given line are the direction ratios of required line. And here the direction ratios of given line are 3, 5, 6. Here direction ratios of required line is equal to direction ratios of given line. Direction ratios of given line. Therefore, the direction ratios of required line is equals to A, B and C, where the direction ratios of the given line are also A, B, C, and the value of A is 3 and the value of B is 5 and the value of C is 6. So we got the direction ratios of the required line as well as the direction ratios of the required line as well as the coordinates of the point through which the required line is passing. So just substitute these values in the Cartesian equation of line. Now what? We know that. Now what? We know that Cartesian equation of required line. Cartesian equation of required line is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c, where 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 x minus x1 is equals to the value of x1 is minus 2. So minus into minus plus 2 divided by a is 3 equal to y minus y1, the value of y1 is 4 divided by b, value of b is 5 equal to z minus, value of z1 is minus 5, so minus into minus plus 5 divided by c, value of c is 6. So this is the required Cartesian equation of the line which parallel to the given line and passes through the point A. I hope all of you understood.